Does the house always win? The short answer is yes, in the long run. All games in a casino are designed in a way that the house will always make a profit, regardless of how lucky some might be. This is due to a law of large numbers which casinos heavily rely on to make a profit. This law, as well as other topics covered in class, will be used to look at their applications in a casino. First, let's talk about what the law of large numbers is. The law of large numbers states that we suppose n is the number of independent trials and n is very large. Let p be the probability of success on each trial. Then the more trials we conduct, the closer to p our relative frequency will become. Casinos rely heavily on this law to make a profit, and also to ensure they are winning the game the majority of the time. The law of large numbers guarantees stable long-term results for the averages of some random events. Applying this to a casino game like roulette, each spin is independent from one another. The probability of winning on red and black bets are 18 out of 38 or 47.37%. This means due to the law of large numbers, as time goes on and the more games that are played at the wheel, the closer the results will be to the theoretical probabilities, or the closer it will be to landing on red and black 47.37% of the time. Now let's talk about this term called the house edge. In every game, the house has an advantage over the player. It does this by lowering the chances of the player winning and also lowering the payouts to the player. So even if the house does lose, they don't pay them the true odds. This advantage is called the house edge. Let's take a look at an example of the roulette wheel. There are 18 reds and blacks. If it was only reds and blacks, the probability of winning is 1/2. This game is not very fun. To tip the scales in favor of the casino, they add 2 greens to the roulette table to make the probability of winning 18 out of 38 on red-black bets. Also in the roulette, they don't pay you the true odds. For example, the odds against winning for single number bets on a roulette wheel is 37 to 1. If you won and the casino paid you the true odds, you get back your original bet plus $37 for every $1 you bet. However, when the casino loses, they don't want to pay you the true amount, and instead they pay you 35 to 1, or your original bet plus $35 for every $1 you bet. The house edge is represented as a percentage, and what this percentage represents is the average profit casinos can expect to make from each game. The house edge on a 0-0 roulette wheel is 5.26%. This means that for every $1 million that's bet at roulette tables, in a casino, the management can expect to make a profit of a little bit over $50,000. The other $950,000 is returned to bettors. Bringing this back to the law of large numbers, the more games that are played, the closer the result will be to the house edge, or the closer the profit will be to the expected profit. The house edge is the casino's expected profit from a game represented as a percent. To see how the house edge is calculated, you just need to calculate the player's expected profit or loss using the expected value formula. If this number is positive, it means that the player makes a profit and the casino makes a loss. If it's negative, it means that the player makes a loss and the casino makes a profit. Let's see how the house edge is calculated by looking at a die rolling game where you bet on the number you think it's going to land on. Let's first look at a fair game. The probability of winning is 1/6 or 5 to 1 odds against winning. These odds mean that if you won, you get your original bet back plus $5 for every $1 you bet, and if you lost, you lose your original bet. While the odds aren't in our favor to win, this is a fair game because the casinos pay you the true odds. Let's say we place a $1 bet on the number 3. If we won, we get our original bet back plus $5 since the odds against winning is 5 to 1. This would mean a profit of $5 if we won, and minus $1 if we lost. Let x be the random variable which represents getting paid x amount, then p of x is equal to x would just be the probability of winning or losing. Using the expected value formula, we see that the expected player profit/loss is $0, meaning a 0% house edge. The casino would expect to make no money from this game. Remember, casinos don't pay you the true odds, which is another way they gain the house edge. Let's modify this game so that the player only gets paid 1 to 1 if they won. This means if you won, you get back your original bet plus $1 for every dollar you bet. So now if you won on a $1 bet on a number 3, you get a profit of $1 instead of 5. Recalculating the expected player profit/loss, we now see that it is minus $0.66. Since the number is negative, it means that the player made a loss. This means on average for every dollar we bet, we can expect to lose 66 cents. Putting it into a percentage for house edge, we just divide by 1 our original bet and multiply by 100 and we get 66%, which means on average for this game, the casino will win around 66% of its total bets and return the other 34% as winnings to the player. Now that we know about how casinos use the law of large numbers to make a profit and what the house edge means, if you're going to a casino, you want to look for games with low house edges. This way, you can play for longer because your funds won't get depleted as fast. Also, keep in mind that the law of large numbers only applies to very large samples, so don't expect results to line up with the theoretical probabilities of winning or the house edge in a small amount of games. Also, keep in mind that deviations are possible, which means short-term streaks are also possible. And also remember independence. Each trial or game is independent from the last. If someone hasn't taken an elementary probability class or doesn't keep what was previously mentioned in mind, it can lead to mistakes and the loss of a lot of money. A common mistake is what's called the gambler's fallacy, also known as the Monte Carlo fallacy. This is the belief that, for example, on a roulette wheel, streaks of red, black, odds, or evens will balance out. This originated in 1913 at a roulette table in Monte Carlo, where they saw that the color black came up 26 times in a row, and bettors started to place large bets on red, thinking that chances of another black were becoming very low. This shows a disregard for independence, as people thought that past spins influenced the next. Another common mistake is what's called the hot hand fallacy, which is similar to the gambler's fallacy as it stems from a disregard of independence. This fallacy is the belief that if a player is on a scoring streak, they will keep on scoring. This also applies to roulette with hot cold numbers or colors and slots with hot or cold symbols. Basically, if a color or number or symbol keeps coming up, it will continue to keep coming up. However, in reality, a streak is just a coincidence and can end any time. As a review of what was presented in this video, we talked about the law of large numbers and how it applies to gambling in both winning and also in how casinos make a profit. We talked about what the house edge is and how it's calculated, and we also talked about what to keep in mind while gambling as well as common mistakes if these tips are ignored. I hope you enjoyed the video and hope that you learned more about the applications of probability in a casino.